Hi class. In this lecture we want to take the concept of differentials and extend it to talk about functions of more than a single variable. Alright, so just to recall from maybe Calc 1, for a differentiable function of one variable y is equal to f of x, we define the differential dx, okay, to be an independent variable, excuse me. That is, dx can be given the value of any real number, so the differential of y is then defined as dy is equal to f prime of x dx. Very easy. Basically, you're taking your dy dx and you're multiplying over the dx here. So now we want to extend this to functions of more than one variable. So let's talk about two variables. So for a differentiable function of two variables, we have z as a function of x and y. We define the differentials dy and dx to be independent variables. That is, they can be given any values. Okay. So then the differential dz is also called the total differential. So this is a little bit different, okay? And it's defined as the following. dz is equal to the partial derivative of f with respect to x times dx plus the partial derivative of y times dy. Or in another little bit notation looking like this. Okay, so sometimes the notation df, all right, is used to replace dz in these cases here. All right, let's just do an example real quick. So if z is equal to a function of x and y, and it's equal to x squared plus 3xy minus y squared, find the differential dz. Then, just as a little bit follow-up, if x changes from 2 to 2.05, so that's my change in x, and y changes from 3 to 2.96, that's my change in y, then compare the values of delta z and dz, and I'll explain that. All right, first off, let's find the total differential. So dz is the partial derivative of z with respect to x times dx, partial derivative of z with respect to y times dy. We see the partial derivative of this function with respect to x is 2x plus 3y times dx, plus partial derivative of this with respect to y, this is just 3x minus 2y. Okay, so this right here is my total differential, my differential dz. All right, now how do we do this next part? Okay, so putting x is equal to 2, dx is equal to delta x. Well, the change in x we see here is 0.05. Y is equal to 3, and dy is equal to delta y. Well, you notice to go from 3 to 2.96, you go minus 0.04. Plugging into our formula, okay, we get the dz, the total differential, okay, the change here, the total change. Plugging these values into this equation we just found, you end up getting 0.65. The increment of z, delta z, okay, you put in these values into the original function minus what you started at, the initial values, 2, 3. If you were to plug this through our functions, you would get this. All right, notice that these two are approximately the same. That's great. That's why we find the total differential. But this dz is obviously easier to compute.